Welcome back, everyone. It's SV Math Teach here. Remember to like and subscribe if you enjoy these videos, or at least if you appreciate the fact that they are free and here to help. Now, with that said, today we're going to talk about comparing linear and nonlinear functions. Now, there's a lot that we can do with this as well, so I've tried to speed the process up by showing you 3 examples. These are all going to be linear, and they're linear for 3 different reasons. On the left-hand side, if you look at a graph and you see that the graphed line is a straight line, and it will continue on being straight, then we go ahead and say that that is linear. In the middle, if you see a table of values, now the table of values is something that you can, you can work on, right? So check this out. With the table of values, essentially what you want to do is you want to find out how your y values are changing, and then how your x values are changing, and then you want to divide the number that's here by the number that's here. And when that happens, you should get the same value every time. Now, I've done one of them for you already. The difference between 21 and 52.5 is 31.50. And the difference between 2 and 5 is 3, right? 2 plus 3 is 5. And down at the bottom, we show that 31.5 divided by 3 is 1050. Now, for what it's worth, doing just one set like I have the red and the blue here isn't really sufficient. What I really need to do is I need to double check all the rest as well. So 5250 up to 63 is up by 10.5, and 5 up to 6 is 1. So 10.5 divided by 1 is 10.5. That agrees with what we had already, so we like that. And then 63 to 105. Let's see, 105 minus 63 is 42. And 6 up to 10 is 4. And 42 divided by 4 is, well, 10.5. So that is, in fact, linear as well, because each one of them ends up being 10.5. The final graph, the first graph was linear because the line was straight. The table was linear because each of the pairs had the same slope. The equation is linear because one of the many ways we can write linear equations is in what's called slope-intercept form. And I think you should be able to see that there's a good, solid connection between my blue generic slope-intercept form and my black example, where 5 is my slope and 15 is my y-intercept. So I could graph that very simply, and that would be a straight line. We also can pull off of this, if we needed to, the slope of each one of these. On the left, the slope is $8 per hour. In the middle, $10.50 an hour, and on the right, $5 per hour. So if this were, well, if I were trying to pick the job, I guess I'd go with the middle one because I make the most money. Now, having said that, let's go ahead and look at a chart that describes linear versus nonlinear. And you can, of course, pause and read this over. But with tables of values, I'm going to go over the linear ones. Tables that are linear have the same slope between any 2 points. We showed that in the middle example up on top. The graphs are all going to have straight lines, and those straight lines will not change. In equations, they're all going to fit into a form that is similar to this one. Even in written scenarios, the changes will increase or decrease by the same number. Like think about a word problem where you earn the same amount of money each hour, or a word problem where you lose a certain amount of weight each week. Those are all linear. Nonlinear are going to be, well, the opposites of those, right? They're going to be not those things. So the slope won't be the same between points. The lines won't be straight. They'll change direction or they'll curve. The equations will have something funky on them. They'll have a square above the x. They'll have a square root sign in there somewhere. They're going to have x in the denominator. They're going to be in some way out of the ordinary. In written scenarios, the changes won't be consistent. They won't be $5 per week or half a pound a month. It's going to be, you're going to earn twice as much every hour as the previous hour. It's going to be something that's really out of the ordinary. Now, an example that I'm going to do in my class is going to be the 4 old judges of The Voice, and we're going to identify which one is and isn't linear. So let's start with the first one. I can see that this line is straight, so linear, right? This is going to be linear all day long. It's also going to be a function because it passes the vertical line test. So this is a linear function. John Legend, right? This is going to be a linear function. And it's a linear function because it fits the form y equals mx plus b. Simple enough. Nick Jonas down here, bottom right. Nick could do 20. I think this must be like push-ups or something, whatever the example was. Nick could do 20 at the start and there it is, doubled. Now doubled means times 2, and that might mean that there's a 2 in there, but he's going to double his number every week. So if he's 20 at week 0, 40 at week 1, then 80, then 160. So if we look at like week 0, week 1, week 2, week 3, this is not going up the same. This is 20 divided by 1. This is 40 divided by 1. This is 80 divided by 1. This slope keeps changing. So this would be non-linear. Sounds like a function, but it's non-linear. And in our table, we have to go ahead and look at this, right? So I'm going to do the same thing. 14 to 20 is up 6. I'm going to use a plus for up. 20 to 22 is up 2. 22 to 23 is up by 1. Now I'm going to come over here and do the same thing. 3 up 2 gives me 5. 5 up 2 gives me 7. And 7 up 3 gives me 10. And what I'll do is I'll divide this number by this number. And I better get the same thing as when I divide the pair below it. So 6 divided by 2 equals 3. Now I'll try again. 2 divided by 2 equals, well, it's supposed to equal 3, and it equals 1. So I'm not even going to do the last combination because I don't need to. This is also non-linear. It's a function because I can see that nothing repeats, and we've already been over that, but this is a non-linear function. So easy ways to identify linear versus non-linear in this video.